Hello, everyone. Good evening. I hope I'm pretty much audible as well as visible to people. Just setting up the screen, guys. Okay, I think we are good to start. So, welcome again, guys, for our today's discussion, where we will primarily be focusing around solution journey, right? So, we always say, how does a data science problem get eventually solved in any industry, right? So when we say a problem statement, we have been discussing around the problem statement, the key matrices, and the major challenges. So now we will rather be summarizing all those points today, and then we will try to understand in a data science industry how a problem statement eventually gets solved, and so what is the entire solution journey looks like, right? So we know that ultimately we are solving the pain point of our business, and that pain point could eventually be anything depending on my industry, to be honest, right? In a data set. And from that regard, we have to understand how exactly we can take up these individual topics one by one, right? So from a solution point of view, we always talk about taking multiple aspects at the same time. So we're going to be talking about how individual steps of my journey looks like. So we have data. So we have been talking about a problem statement. And to solve that problem statement, we know that we have certain set of data with us, right? So for that data, how that data comes, from where that data comes. And if we have that data, how we can take leverage of that data to solve a business problem, right? So, and in fact, the moment we talk about this data, nobody is going to spoon feed us with this data, right? So, collection process itself is one of the major steps in my solution journey. And then we know that the moment we start collecting our data, we have so many problems in terms of formatting, in terms of having multiple challenges in my data. Then we talk about multiple different things, right? So after having the data collection process, we talk about the data cleaning process, right? So that's where again a major problem comes. So data cleaning also plays a very crucial role in my solution journey. So we have to understand my data cleaning part as well. So we will be discussing about again that as one of my crucial steps. So it is more like multiple things which is happening in the background, which is ultimately resulting in our end solution, which we are seeing as a business solution, right? And even from the academic standpoint of view, we say that we have a project. So project is a problem statement which we're trying to solve, right? So from an academic standpoint of view, you might not be get totally engrossed in one of the other steps, but still things fall in place likewise for you as well. So we're going to be discussing even that regard as well. So that's pretty much what the agenda of today's discussion would be. So talking from the solution journey point of view, right? So let's get started on this, guys. Uh, as always, before proceeding further, just a quick introduction about myself. My name is Arpit Jain, and the only reason I am here because data science is what my passion is, and I really like sharing my expertise with people. Where I've been around in this industry for quite some time, and then having solved multiple problem statement in and around data science, so into multiple aspects of it. Along with this, I'm also a motivational speaker, so I do talk to students regarding their career placements, jobs, so anything in general as well. Please feel free to reach out. It's pretty much a live session, so I am monitoring the chat. So any questions coming up here, I'll be more than happy to take it up. Okay, so that's a quick introduction about myself. Agenda, as I was talking about, I will be primarily focusing towards my solution journey, right? So when I say a solution journey, let's try to frame out few of the keywords or few of the interesting aspects of my solution, right? So first and foremost, we're gonna be looking around data, right? So data again has two practical challenges. First is data collection. So from where to collect, what to collect, how to collect, right? So all of these major problems, what you can think of, like what data has to be collected. So for that, you need to have some business level understanding. You need to talk to your subject matter experts. You need to understand your problem statement, your own statistical understanding. And from those factors, we frame out, okay, we want to extract this, and this data. Okay. So that's basically what to extract. And then we talk about from where to extract, right? So where to extract, again, every single source, every single data will have some source. Like it might be residing in some database, it might be open available on public websites or something else as well, right? So we find out a measure to collect that data. We might be writing a SQL query to interact with the databases, or we might even write the Python queries, Python scripts to extract it from the open sources, right? So collection itself is a separate ball game. We will be going deep here. So we will try to understand what all problems are involved in the collection phase. Very important phase, in fact. And that is where you generally feel in terms of academics, people don't have much what to say, exposure here, because in academics, we are generally fed with or given with some Excel file or CSV files, which would be the direct problem statement, and then saying that, okay, based on this data set, you are expected to solve something, right? So collection process generally in the academic phase loses out its the core importance, but that's perfectly fine. That's still okay itself, because even in the collection phase, we always talk about a lot of different skills. That's where SQL might come into picture, Python might come into picture, right? And we know that these are anyway my prominent skills. Even though you do not have a direct collection experience, but you might still have worked on those skills, which might sufficiently say that yes, you can still take up that job, right? But again, we will be discussing in detail, like on the collection phase, what all things would be required. Then we talk about cleaning phase, right? So in the cleaning phase, we say that now we have to understand what all things would be required to have the right set of information. So we might have collected something which is not in a pretty much usable format. And when I say usable format, there are a lot of things which we have to understand. So it might be unknown format, or it might be a messed up data. When I say messed up data, not so clean data, lot many challenges from the data standpoint of view. So all those cleaning process, exploration process, that's where again my part of data comes into picture. So we always try to first understand what exactly does this thing comes into picture. So data collection, then data cleaning, and more like exploration of my data comes into picture. So that's where we talk about from the data standpoint of view, solution journey. And then we will be discussing on both of these steps one by one in detail. Second, we talk about the model. Little hyped up here as well. So here we talk about AI, ML, right? So whatever data which has been collected, which has been cleaned, which has been explored, this gets cascaded to my model built up phase, right? So it's not like you're going to be doing analysis or cleaning on some random data, and then for model there something else would come up. No, it never happens like that. It's more like a sequential process. It's not a parallel process, more like a sequential process. So model build-up will only be applicable for AI ML once we have this respective information. So once we have this data, which is pretty much cleaned, collected, now I am trying to apply the artificial intelligence or the machine learning algorithms to specify my trends. And then if once the trend has been generalized, that can be used as a forecasting mechanism or the predictive mechanism for future. So model build-up phase comes into picture. Again, even in this phase, we have a lot many challenges. So many algorithms, what to choose, when to choose, right? So again, problems comes into picture, and we try to talk about the different set of algorithms, and then based on the business needs, what to choose, right, and how to choose. So those things comes into picture here. Again, pretty much part of my solution journey. And obviously, each of these phases have its own requirement. If you realize, we are pretty much into a research part, right? So when we are exploring the data, when we are analyzing our data, it's more like a research thing which is happening, exploration which is happening, right? That takes time. But from the model perspective, we have to understand, again, we are into the selection process of my model build-up, but end objective is to get the best model performance. So then we always try to understand the time requirements in both the areas. We'll again anyway understand it with time. Third phase, once the model is ready from the data which was collected and cleaned, then we talk about implementation. Right? So implementation phase is basically, again, we talk about two things here. We talk about first communication. So in few cases, my implementation would be just to communicate my business results and present what we have observed as a trend, like a statistical analysis which is happening. Second, it could also be more like a deployment which is happening in my system architecture. So it could be like a deployment, right? So in this deployment, what do we get is we need to understand what would be required in terms of deployment. So is it like a complete stack, or what kind of infrastructure we need? And obviously, even this will have n number of problem statements involved, like deployment stack, what kind of system design we have, what kind of different architectural blocks I'll be using, what kind of cloud platform I'm using. Is it scalable? Is it robust? Is it secure? Is it fast? So many questions again, right? So this is how the entire solution journey would be looking around, and we will be anyway taking each of these steps one by one. So data, modeling, implementation, so everything will be covered likewise as our pointers. Okay, so let's get started on this with this notion. That's what pretty much what we're trying to cover. Before that, as always, one quick quote for you. So the world is one big data problem. Very rightly said, isn't it? Everything you are seeing around is basically one big data problem. Whether I have received my salary or not on time, what kind of information I am getting from there, or what kind of people are around me, whether I have electricity, what kind of shows I'm watching, what kind of social media blogs I'm reading, or whatever is happening around me or entire world is basically we are generating some or the other data, and which internally is creating the big data problem. So yes, very rightly said, we are or we are in the world where it's more like one big data problem. So whatever you see around you, whatever you you see what's happening around you is basically part of that data problem, right? So that's pretty much what we have. So with this, let's get started. A quick detailing about what is data science first, and then we'll move towards the data science solution. So data science, as you know, is the domain of study that deals with the vast volumes of data. So when I say the vast volumes of data, it is nothing but we are talking about a humongous number of data, or the volume of data. Or when I say volume, I solely don't mean only the volume. I also mean the variety of data what we are talking about, right? So many varieties, so many different forms of data we are seeing, different sources, and the volume is so tremendous because we're talking about having this generated every single second. So we are seeing so many things happening around us. We are in the digital world where we are generating so much of data, and the domain which studies and deals with this vast volume of data is pretty much what data science is. And for this studying purpose, this uses the tools and techniques to help find the unseen patterns and thus find some meaningful information, eventually helping the business take some relevant business decisions. So yes, since we're talking about study of my data, the vast volumes of data, that needs some type of tools and tech. And eventually, the end objective of these modern tools and tech is to find the unseen patterns and then derive the meaningful information and thus making some business decisions. And the data which is used for analysis can come from different data sources. So we have been discussing around this. So the data used for my analysis purpose is pretty much vast. It is coming from different data sources and also presented in various formats, right? So we are talking about data which is used for my analysis purpose, and it can come from multiple different sources. And what are these sources? I could talk about probably something coming from my web, or coming from my databases, or coming from my backend services. So wherever, whatever you can think of, there could be different sources of my data. And also, this could be in multiple other formats as well. It's not necessary that it's going to be in a tabular format. No, it could be an image, it could be a graph. So likewise, all of this become one of the other entry points and one of the other discussion points for a data science team. That's where they try to understand and study these vast volumes of data which is coming from different sources and different formats, using the multiple different tools and modern techniques to derive the meaningful information from the patterns and take some business decisions. Right? So let's try to understand how does it work. Okay, let's try to take up the phases. Let's try to understand how overall data science journey looks like. Okay, so the very first step on your screen which you see right now is my data collection phase. Okay, so this is my prime first phase where we talk about data collection. Major questions are what to collect, how to collect, from where to collect, and also sometimes when to collect. So all of these are very standard problems from the data collection standpoint of view. So what does it mean? When I say what to collect, I do not know if I'm trying to solve a particular business problem. Okay, this data will be the actual one which will help me solve that problem, right? So then we always talk about my problem statement. And this is what we have been discussing around so far, right? So in the last 2, 3 sessions, we have been engrossly discussing about my problem statement. So if I have a clarity on my problem statement, so and obviously with that, we have to discuss it with my subject matter experts who are day in and day out working on those problems. So from the data standpoint of view, collection agents or what expectedly I'm going to collect is going to be answered by my business problem. So what problem I'm trying to solve, that eventually will be helping to solve this problem, what to collect. And to answer the question how to collect, we have to first understand from where to collect it, right? So this, I think, would come first. So from where to collect. So now we have to understand that, okay, I have my data set 1 or my feature set 1 till feature set 10, which I want to extract, or which I want to use, or which I want to collect for my problem solving purpose, right? So now in terms of identifying these feature sets F1 to F10, how do we see these things happening? Now, if I have these data sets F1 to F10, I know maybe suppose F1 till F3 is present in my database 1. Yeah. For F4, I might need to go to my website abc.com. Likewise. So I have to first identify like these are my potential list of feature sets which I might need to solve this problem statement. And from then I have to identify where exactly each of them are present. So we're going to answer this question where exactly these are located. So I'll get multiple different resources depending on my problem statement. Then comes the question how to collect. So if it is a database, we might be writing a SQL queries. If it's a website, we might use Python or something else to extract, or some other scripting language to get the data from their respective sources. And also there is very important question when to collect, right? So now when we say when to collect, it always talks about identifying the right timings. So for example, when I say I have a problem statement which I want to use or which I want to solve on, and I'm looking at the time component there. So for example, say weather information. If I want to solve a problem on weather information, I need to have a pinpointed collection of my data which has to be there, right? If I want to predict what's happening right or what is happening right now, what might happen after some point of time, I need to have the collection agents, or I need to have this scripting running at the right time, right? Maybe I'm looking for a generic trend, so I'll maybe look for 12 noon or 12 midnight, or every second. So frequency would be every second, or maybe every minute, or every hour. So time component of my collection also becomes quite important here. So first phase, prominently, we talk about data collection, and internally, it definitely solves these many problem statements. So I am talking about solving these internal questions when I'm talking about a data collection problem. And obviously, yes, when I talk about from an academic standpoint of view, you might not look at solving all of these individual questions on academic fronts, what to collect, how to collect. Because in academics, we rather get an extracted CSV file or an Excel file, and we start exploring on that. So this is one of the phases which is not truly applicable for an academic side, but yes, from a business standpoint of view, it is valid, 100% valid. We talk about taking care of each of these individual steps or individual pointers one by one, and likewise, we try to solve the business problem. I could see a few chat points here. Concept graduation, you're feeling confident. You're asking me or you're telling me. Okay, I didn't get that. Speed up your tone. I can. I mean, but I think going too fast might deter something from what I want to explain. But again, if you think that, I'll try to be. I try to. नीतीश पूछ रहे हैं डेटा साइंस कोर्स करने के बाद जॉब लग जाता है 100%। अगर आप स्किल्ड हैं नीतीश तो डेफिनेटली लगेगा, क्यों नहीं लगेगा। और बट ऑनेस्टली देयर कोई गारंटी नहीं है किसी भी चीज़ की। अगर इफ आपको कोई ये कह रहा है कि आप ये कोर्स कर लो एंड देन डू दिस डू दैट एंड यू गेट अ जॉब, आई डाउट, बिकॉज अल्टीमेटली जॉब फोकस्ड है आपके स्किल पे। इफ यू थिंक यू आर एबल टू get what is being taught to you, definitely you'll get the job, because ultimately skill matters. Whatever degree, whatever certification you're thinking of, it is the additional plus. Whatever guarantees a job is your confidence, and that confidence will only come if you're skilled enough, right? So ये मत सोचिए कि कोर्स करने के बाद आपकी जॉब लग जाएगी। कोर्स करने के बाद आप सीख जाएंगे, है ना, आप समझ जाएंगे, एंड उस सीखने से, उस समझने से आपकी जॉब लगेगी, ना कि कोर्स करने से। तो ये जो क्लैरिटी ऑफ थॉट बहुत जरूरी है। ठीक है नीतीश, आई होप दैट आंसर्स योर क्वेश्चन। चलो कूल है, बढ़ते हैं। ये हमारी फर्स्ट फेज। आई होप यू आर एबल टू अंडरस्टैंड गाइस। डेटा कलेक्शन फेज में भी हमारे 50 चीजें हैं। वी हैव सो मेनी थिंग्स which we have to actually handle in data collection phase as well, है ना। So अभी data collection phase में इतनी सारी problem है, so how are we going to solve other things now, right? So what is my objective now? How I'm looking at other problem statements. We have another question: how we extract data from MySQL? Simple है। So MySQL, I mean, depend करता है what kind of platform you have in your industry. So that database, Oracle database, or SQL database, SQL Server. So basically, we connect our servers from there. So instead of like the way you set up a local host machine, right? Like the way you can set up your database, which might be having an IP address, right? IP address, password, root, table. Then ultimately, once you connect, you write your same SQL queries. And once you have a SQL query, that's like a one-time process. But from a business standpoint of view, we try to write some PL SQL statements, like a procedure, right? Which is more like a shell script which can be executed, which is kind of running your SQL query at the end, giving you the results every time whenever you want it, right? So it's more like we are creating a procedure, like a statement which can be executed multiple times, right? So something of that sort happens in industry, but at least I think it is too early for you guys to explain you that. But it can be done. It's more like on the same machine which you're doing right now, we connect your business setup. Obviously, some security firewall setup has to be done. Likewise, once your database is selected, the way you're doing select star from say table, whatever table, like the way you run your query on MySQL there, or whatever SQL server, depending on your industry, right? Same simple SQL queries. Okay, I have another question. I'm dealing with weather data set. So thing is that I'm not able to impute null values by mean median mode. I'm not getting when to use. You're not able to impute null values. Depend करता है what kind of trend you have, right? So generally, mean median mode जो है more like very statistical method of imputation, right? जरूरी नहीं है कि we are supposed to do only with mean median mode. The problem is of null values. जिसका solution mandatorily जरूरी नहीं है, it has to be mean median mode. So always think it from that perspective. Don't be a machine here, okay? From a data science perspective, you have to first experiment. You can do anything, you can do any imputation. What will happen if you replace the missing value with 0? Do you think you will get a letter from a Supreme Court saying that, oh my God, you've done something really bad. No, right? So you can do practically anything. It's not only mean, median, mode, right? Obviously, you have to understand it's not always mean, median, mode. Like for example, here weather data. It's more like a auto-correlated data. Like morning's data might be dependent on afternoon's data. Afternoon weather might be dependent on the evening. Something of that sort. Or evening is dependent on the afternoon data. It's more like correlations are there, right? Something of that sort. By this trend, you can imagine maybe a backward filling or maybe a k nearest neighbor filling. Something of that sort would be helpful, right? Or maybe you can choose last 2-3 records and then take a mean of that. So try to be smart enough. Don't think that only by doing this your job will be done. Then you're becoming a machine. Then why you will be hired for the organization, right? This can be automated. If it has to be filled by mode for categorical data, or if it has to be filled by mean for numerical data, why do you think you are getting hired for? It can be automated, right? The reason why you will be hired is to tell you logic, right? Which a machine cannot. So you have to understand it, understand the data, feel the data. That's where the pattern identification comes into picture, right? That is what the second phase I'll be talking about. So if you look at this, my second phase is prominently will be talking about, you can see data preparation, right? And this data preparation involves a very crucial step of analysis, data treatment, feature engineering. All of this is very important, right? Then we try to understand, okay, because I have something of this trend, this is how I can maybe, clean my data. This is how maybe I can replicate things. You're getting my point? So it is purely dependent on what data you have, and accordingly, you have to prioritize your understanding on this, right? So for example, the case what concept graduation is saying, for his or her data, I believe that it's more towards, taking the nearest data, maybe a backward filling, or maybe a forward filling also could help here, depending on what kind of trend you have. So maybe mean, median, mode might not be an ideal data here to replace with, right? So don't be a machine, try to understand the data first, okay? Cool, coming back guys. So second phase here, if you can see, this is my second phase. And in this second phase, I'm going to talk about data preparation. So data preparation, where it involves analysis, data treatment, feature engineering. What does it mean? Okay. So that purely is going to intent here in this phase, data preparation is basically to extract or to get everything what data is talking about. So we're trying to talk about getting the hidden patterns. If you can understand the data well, if you're able to get what is the information within your data, the hidden patterns, right? That is where my analysis phase comes into picture. We always talk about, cleaning my data with multiple things. We talk about in cleaning steps, missing value treatment. We talk about outliers, right? We talk about correlations. Then we talk about skewness. So a lot of things are there. These are what we try to analyze our data on. So analysis is basically comprised of all of these multiple steps, right? So it's all about understanding my data, and it's all about finding out the right thing which is needed to maybe get your job done, right? So, and each of these steps is not like a robotic system which you have to do. It's about understanding and getting a feel of my data. For example, I have a missing value, like the way we got the question today. This can be treated in like 1,000 ways. Trust me on that. Right? I can treat a missing value with 1,000 ways. And can anyone give me in writing that, okay, replacing missing data with mean, or replacing missing data with mode, or replacing missing data with zero, or removing a missing data is the right technique? Can anyone give me in writing? No. It is very subjective to my data. I need to understand, right? So, for example, I think I get your point, concept graduation. You are new to this, so we need to understand it. Okay, so we need to get a feel of my data. So, कैसे करेंगे इसको? For example, now I'm trying to see the trend of my data. Okay, so I'm seeing that okay, trend is something like this. Okay, and I have a missing data somewhere around here. Okay, what will happen if I replace the missing data with mean? Can you see these are some high points here? So mean will be heavily distorted. So this, instead of getting replaced by similar value, it will get something like this value. So the trend will become something like this, which is wrong. Correct? Or so situations like these, it demands that the value are autocorrelated. Autocorrelated means simple. We talk about the current value is dependent on my previous value. Yeah? So situations like these, I would rather prefer doing a backward filling or a forward filling or a nearest value, something like that. So it is very subjective. Likewise, outliers. Outliers, we have a very standard mechanism called as IQR. Most of us know that. So, but is IQR the only method? No. I can use a percentile capping 95, 99, 97, 98. Nobody is stopping me. I can do whatever I want. It depends on my data, right? So try to be a bit innovative here. Try to understand your data. Try to get a feel of how it happens. And that's where the data preparation step comes. Trust me, guys, this is the step where a distinction between a data scientist and a good data scientist happens. Z-scorer, yes, absolutely correct. Yes, one of the steps, statistical analysis, hypothesis testing, right? So these all comes in data preparation steps. So this is the place where you and other data scientists get differentiated on, right? Because this is a pure experimental stage. This is a pure research stage. Your thought process, how well you can think about your data, how smartly you can get the imputations done, how smartly you are able to create some new engineered features, right? That's where the data preparation comes into picture. And this is the most crucial step of my solution journey. And this is going to create the distinction between you and any other data scientist. And that's where maybe you are not getting shortlisted, maybe somebody else is getting shortlisted for the interview process, because it's not about he having something else, it's about he able to explain the concepts of or the logics behind the using of all of these analysis more logically. That's where the difference comes. So you have to always understand that data preparation is my most important step. It is not machine learning. It is not AI/ML codes. AI/ML codes are hardly 5 lines of code. You import from scikit-learn, you train, you split, you fit, you train, you predict. Nothing else, not more than 5 lines of code. So ML algorithm stage is the last stage, 10% of effort, nothing's there. Your 80 to 90% of your effort goes in this step. So this is my most important step. So if your data analysis is good, if your data preparation is good, you are expected to get good results from your model. Right? So that's how things work. So I hope that makes sense. Now, post this, this is practically what my second page talks about, guys. So we talk about preparation. Post, in fact, if you understand what's happening here, so many things. It's not only about doing the analysis, also about creating some new feature sets and whatnot. Cool. So, what happens, guys? Just a minute, I think. Something happened. Just a minute. I lost my content. Just a minute. I'm just rechecking it. Cool. So this is what my second phase is. So we're gonna remove it now, move to our next phase. So next phase is pretty much what we talk as a model built up phase. Okay. So model build up phase again is my one of the important steps, but it comes after my data preparation. So model building is my third phase. That's where what we do is there are two, three important things here again. First, model selection. Second, we're gonna talk about model evaluation. And then we talk about tuning. So this step, basically my third phase, we're gonna talk about what are my different algorithms and what are my different checks or different models which we have, which we can implement. And then according to this model selection, my different models which we have, how I'm going to evaluate my model, what will be my evaluation strategies, right? So model selection, post this model selection comes my model evaluation phase, right? And on that model evaluation, then I'll be talking about my model tuning. So let's talk about each of them. So we have been discussing about the different problem statements. So if it's a classification problem, obviously I cannot apply a regression algorithm there, right? So every business problem has certain pool of algorithms from which it can be applied on. So suppose a problem statement has a pool of 5 qualifying algorithms which can be used, right? So once we have kind of shortlisted this 5 algorithms, it is not like now I have to just pinpoint and run out only one of these. No. Now, once we have shortlisted these 5 algorithms, we can pretty much run our model on a loop on maybe all 5 of them, because they all are equally valid for my problem statement. I can do that. And once we have identified these 5 algorithms and we have run our analysis on all 5 of them, we can pretty much evaluate it. Evaluate it means which algorithm is better or what not for me. So model evaluation would be more like identifying the right set of solutions for me, or evaluating which one is better. So again, an evaluation criteria, we talk about right metric. So again, every problem statement has a different metric. So classification, maybe we talk about true positives, or in regression, we talk about the residuals. So then we talk about the evaluation strategies. We'll be discussing about these evaluation strategies in detail in upcoming videos. But more like it's about identifying a metric which is giving me a clarification of, okay, based on this, model 1 is better than model 2. Something of that sort, right? So then we're going to say that identifying the right metric for my solution. And suppose I have run all the model, I have identified, say, algorithm 3 is giving me the best performance out of all of them. Then comes the phase of tuning. We run multiple iterations and then we try to check in terms of experiment what all different argument or what all different model parameters can be changed so that we can further improve the performance. That's where tuning process comes into picture. So again, we will study about this once we get into the machine learning part. So model selection followed by model evaluation and then followed by the hyperparameter tuning, like a tuning process. We're going to further improve the model performance by some odd percentages by running some multiple experiments and multiple iterations. Cool. So this is what my third phase of model building talks about. Then comes the fourth stage of communication. Again, this is very important phase, guys. Fourth stage, communication. And if you remember, I have told you communication is one of the very prime skill set of a data science professional. If you are not able to communicate your result to the business leaders, to the right stakeholders, and if you are not able to convince them with your analysis, your experiments, your results are of no use, right? So this stage prominently means that how you are demonstrating or how you are showcasing your results to the business, right? So prominently how you are communicating your results to the business, and that definitely includes my business results, my usages of these, and the respective benefit and its application. So how am I going to use this information for my business benefit? So trying to have a story behind this, trying to understand how this would be used, and trying to see if based on this analysis, how business can be benefited. So more like a story around this, right? So what was the problem statement, what you have analyzed, and based on this, how you can make sure that you can help the business. So more like a story around this area where you are going to talk about your entire solution which you have done so far, right? And then ultimately finding out how you will be helping your business, right? So that's pretty much what the communication phase talks about. Again, guys, slightly overlooked phase for a data science field, but trust me, this is one of the most important phases again, where you have to talk about your results in terms of good presentation, your own confidence, and then you communicate it to the business, right? Then comes our last phase, which is my implementation phase. My next phase, my last phase, my implementation phase. That's where we talk about how exactly we're going to use this for my communication purpose. So now once we have communicated our result, we're going to implement it. Implement it means now whatever results I have, we have to implement it to the business. Like for example, I have a cloud architecture. So I want to use my cloud architecture, whatever I have built up, for the deployment purpose. So productionization of my solution, the live feeds, that's what we talk about, is going to be part of this. So I'm going to deploy my solution into my business, right? So software engineering, my cloud architectures, my data build-ups, my productionization of my model, all of these would be part of this. So data engineering field gets into involvement here. And whatever we have built up as part of my model, we're going to productionize it for a real-time business usages. So guys, that's how the overall journey of a problem statement looks like, from the collection phase till the implementation phase. And obviously, as you have understood, each of these steps also has their own respective challenges. So we talked about the collection phase challenges, preparation, the most important phase, the model build up, and then the communication implementation. So all of these phases combinedly talks about the entire solution journey of a data science problem. Cool, guys. So to be honest, this is how the entire solution journey looks like. And when I say the problem statement, so this is what we are trying to solve. And ultimately, this is what I intended to cover also today, guys. So thank you so much for being patient and listening to me. I'm open to any questions, guys. I hope that makes sense. So this is how the solution journey looks like. So please feel free to ask your questions, and do let me know if there's anything in which I can help you with. So more than happy to take your questions. Intended to cover also today, so patiently listening to me. Any questions, guys? Any last moment questions which you want me to ask? Cool. Great. So with this, thank you so much, and I really appreciate for everyone to be patient and listening to me. So with this, guys, we are done with our today's discussion. So we're gonna meet up again the next day with a new topic. So we'll rather go towards in detail of now the metrics we were talking about, right? So there are so many metrics. So we'll go in detail about these metrics one by one. So that's pretty much what the agenda would be, guys. Cool. Thank you